Hi, in this video I will explain the concept of chromatography, which is one of the most common techniques that is used in organic chemistry labs. Chromatography is the separation of a mixture of two or more compounds into its constituents. In chromatography, we have the stationary phase, which is usually the substance that interacts with the mixture and causes the separation, and we have the mobile phase, which is usually used to push the mixture to move over the stationary phase. There are several types of chromatography, but in this video I will just focus on two of them, which are commonly used in undergraduate organic chemistry labs, and these are the column chromatography and the thin layer chromatography. In the upcoming sections, we will explain each of these in details. So how does the separation take place using chromatography? We know that different compounds interact in different ways with the stationary phase. So some compounds, because of their intermolecular forces, they will be strongly interacting with the stationary phase, whereas other compounds will be weakly interacting with the stationary phase. If the compound is strongly interacting with the stationary phase, then it will be delayed, and it will take some time for this compound to get out of the column or to move over the plate. Whereas if the compound is weakly interacting with the stationary phase, then this compound will be moving fast and it will get quickly out of the column or move over the plate. And that's how separation happens. So let's explain now the concept of column chromatography in more details. Column chromatography is mainly used to purify compounds by separating them from impurities. So if I have a compound which is contaminated with impurities and I want to get rid of these impurities, I can use column chromatography to purify this compound. Or sometimes we use column chromatography to separate a mixture into its constituents. So if you have a mixture which consists of two or more compounds and I want to separate and isolate these compounds, I can use column chromatography. Usually column chromatography takes a long time. It may take 1 hour, 2 hours, 3 hours, and so on, depending on the length of the column, the amount of the material that you are using, and the rate at which the separated substances are moving out of the column. So how does column chromatography work? In column chromatography, the stationary phase will be mainly made up of silica gel, which is a polar compound, and the mobile phase will be usually a mixture of solvents, a polar and a non-polar solvent. So if we have a stationary phase and we have a compound or a mixture of compounds which are added or loaded to the stationary phase, so this is the picture of a column which is used in column chromatography. The blue material is usually the silica gel, and this is a place where we added our sample. So this is where we add our sample. Now once your sample is added and the mobile phase was added to the column, the mobile phase will try to push your sample to go down the column. The stationary phase, because of its high polarity, it will start to interact with the mixtures that you added. Compounds, let's assume that we have two compounds A and B which were added to the column. Compounds A and B will interact with the silica gel. However, if we assume that compound A is a polar compound, then this compound will be strongly interacting with the stationary phase. Whereas B, which is a less polar compound, will be weakly interacting with the stationary phase. Because of this strong interaction, the mobile phase, which is trying to push both compounds to move down the column, will be able to push both. However, A will be moving slowly. Why? Because A is strongly interacting, or it is strongly attached to the stationary phase. B, which is weakly interacting with the stationary phase, or B, which is connected or bonded to the stationary phase with weak bonds or weak interactions, will be moving quickly. And that's why if we just look back at this image here, we can see that as with time, we can see that this green band, which corresponds to compound B, will start to move slowly down the column, whereas compound A, which is this brown or orange one, will start moving slowly, and that's why with time B will reach the end of the column and it will be isolated, and A will still be in the column. After some time we can push A also to go out of the column, and this is how separation works. Polar solvents will usually cause the molecules to move quickly and fast, whereas non-polar solvents will usually cause the molecules to move slowly. And that's why the best option is always using a mixture of both. So in most of the times in column chromatography, we will be using a mixture of a polar and a non-polar solvent, because if the solvent is too polar, then all the material will be moving fast, and that's why separation will not be good. If the only a non-polar solvent is used, then the separation process will take a long time, and sometimes the compounds will never get out of the column. So it's always better to use a mixture of a polar and a non-polar